Hi everyone, welcome to today's lesson. So today we are going to be revising financial maths. This is going to be mainly just past paper questions that we have adapted from the past papers that we're getting out there to try and show how all of these concepts of financial maths come together and how you can then tackle them based on whatever the question is asking you. So for now, let's just map out everything that financial maths is all about and then do the questions together. So remember that with financial maths, we have what we call the future value, which has to do with the sinking fund, and it also has to do with annuities, right? So remember, annuities, this will be the monthly payment that you make on a regular basis. Or rather, let's not call it monthly. Let's say it is regular payments that a person makes, because at times it can be quarterly, at times it can be semi-annual. Some people make payments that way. And then also with the present value, this will be something you have now, which is a bond repayment, because when you go to get a bond, you don't have any money. The bank is the one that gives you everything. And also a loan, which means you don't have anything at that time and you are getting money in order to make it zero at the end, like your balance. Now, the following formula is used to calculate the future value annuity. Remember, it's F. Some people prefer using FV. Really, it's entirely up to you. As long as the F is there, what you add next to it does not really matter. And then it's X, which this we know is our monthly payment, or that is the amount we pay on regular intervals. And N will be the number of payments. Number of payments, because it's not always in years. Not always in years, right? Because it can be at times months, it can be quarters, it can be half yearly. And then the last thing will be the interest rate as a decimal. So if I give you 20%, you know this is the same as 0.2, and then you will divide it by the compounding period at that particular time. Now, just a question for us to try and look at here. So they say on 30 June, now this is very important because this is what is going to assist us in trying to get how many years or how many months this investment, if it is an investment, was. And at the end of each month thereafter, right? So 30 June, that's month end. So meaning month end of July, month end of August, month end of September, like that. Asif deposited 2.5 into a bank account that pays an interest at 6% per annum, compounded monthly. Now he wants to deposit this until 31 May 2018. So you can see that from 2013 to 2018, this is 5 years. And also it makes sense that it's 5 years because it's from June to May. That makes it 5 years, the end of May, by the way, that is. So if you look at the end of June, that will cover the actual 5 years. That extra month is for when the money is still getting some interest for one last month. Now calculate how much money Asif will have in this account immediately after depositing on 31 May 2018. Now, let's try and talk about this a bit. Asif wants to open this account, right? Month end of June, decides to say, I'm going to pay out 2.5. And then at the end of every month thereafter, I then will add another 2.5 on a monthly basis. And I'm starting this 30 June to 31 May. So it means from 31 May to 30 June, right, there will be 1 more month of it having to mature in that particular bank. So that's what makes it 5 years instead of maybe 4 years and 11 months, because someone might say that. Then the other thing is, the reason why we are not adding or subtracting number of months or anything like that, it's because if Asif had made a payment beginning of the month, and then month end, and then month end, so that would mean the first month Asif would have made 2 payments into this particular savings account. But that was not the case. It was month end, then month end, then month end. So that's how I want you guys to please make sure that you think about this. So let's just write down our data and see how we're going to solve this. So with our data, we know that F is something that we need. That's how much ASIF will have at the end of the duration, which is 60 months. And it is 2.5 that is being paid into this investment. 5 multiplied by 12 because it is on a monthly basis. And then the interest that we are given is 6%. Compounded monthly, which makes it 0.06 over 12. Now we know as soon as we have this, I'm going to say F is equals to X into 1 plus I to the exponent of n minus 1, all divided by I, right? If you are not sure, always go back to the formula that you have in the information sheet in order to know what is it the formula supposed to be. Then this is 2.5 that I have there into 1 plus 0.06 divided by 12, all raised to an exponent of 60, then minus 1. All of this is divided by 0.06 over 12, and then you go straight to your calculator. You don't even need to crack your brain with trying to solve that manually. So this is 2.5, open bracket, another bracket, 1 plus 0.06 over 12, all raised to the exponent of 60, minus 1, close the bracket, over another fraction, which is 0.06 divided 0.06 divided by 12, and this will give me that much. So ASIF will have 174,425. So this is 174,425, and how many cents? And 8 cents, because we're going to round this off to 2 decimal places. Therefore, ASIF will have, so you will need to make a conclusion, right? 174,425,08 in his account after the 5 years. So you can always include that part there at the end, depending on what they wanted you to do. So you always need to try and make a conclusion from what you have calculated, because at times the calculation is not so clear on what is it that the person is trying to do. So I hope that just refreshes a bit of memory. I want us to take a quick ad break. When we come back, we're then going to do more of these questions using the future value formula. Please stay tuned. I'll be back just now. Hi guys, welcome back. I hope you are refreshed and you are a bit feeling forward, or looking forward rather, to actually answering these questions with me. I hope the very first question we did was like an eye-opener of what we are going to try and do. This one is particularly going to be very interesting, the question we are going to do now, because I want you to really pay close attention. I'm going to try use a timeline for you to be able to see how to analyze this question. So please try and be with me here. Then wherever you do not understand, just quickly write it down so you can always go back to it when you are trying to study again on your own. So the question that we now have to do says, Selby decided today that he will save 12,000 per quarter, right? Over the next 4 years, right? So not for that way. The next 4 years, he will make the first deposit into a savings account in 3 months' time, and he will make his last deposit at the end of 4 years from now. So you can see what this simply means is If I'm going to consider this as a 4-year period, this is going to be T0, right? T0 will be when he makes the deposit, right? And it will go up until it gets to the 4 years. But in terms of the 4 years, it is going to be divided into quarters, right? The ones that will make each year. So this will be T1. So that will be the end of the first year. So the first deposit will be there after the 3 months, second deposit, third deposit. So you're not cutting any deposit. It just simply tells you that this person will make, which is Selby, will make the payments on a quarterly basis for a period of 4 years. Now, what I want you to do, or what we are required to do, is how much will then Selby have at the end of 4 years if interest is earned at 8.8 per annum compounded quarterly. So what I want you also to understand about this question is there is no way that this person will be making quarterly payments, but the interest is charged on a monthly basis. Really, that at times that does not really make sense. Even the financial institutions themselves will not really grant something of that sort. So it's always going to be, if it's quarterly basis, then it's on a quarterly basis. The interest itself is charged on a quarterly basis because your payments are quarterly. If your payments are monthly, the interest is normally going to also be given to you on a monthly basis. So please just try and link those two at all times when trying to do this. Now, to look at our data, we know that Selby is making payments of 12,000, and this is for 4 years, but in 4 years, we know each year has 4 quarters, so that makes it 16 quarters, and then 8.8% compounded quarterly will be the same as 0.088 over 4. Now I will need to substitute this in the future value formula, which is F is equals to X into 1 plus I to the exponent of n minus 1, all of this divided by I. Please make sure you start by writing the formula before substituting anything. Therefore, this becomes 12,000 into 1 plus, my I here is 0.088 over 4, all raised to the exponent of 16 minus 1 divided by 0.088 over 4. You are more than welcome to write 4 multiplied by 4 there instead of 16. That really means one and the same thing. Now, on my calculator, this will be 12,000. Open those brackets. 1 plus 0.088 over 4 raised to the exponent of 16 minus 1, close the bracket, over 0.088 over 4. And then this will be 227,000. So this will be 227,000, 177.82. 177.82. So therefore, Selby will have 2,000. Now I'm thinking 1,000. So this will be 227,177.82 cents. And that's how much Selby will have at the end of the 4 years. Now from there, same statement, but now Selby decides to withdraw 100,000 from the account at the end of 3 years. From now, right? How much will he then now have in the account at the end of 4 years? So I want us to try and paint this idea on a number line, right? So there are payments of 12,000 that Selby is making into this, and the payments are going to last for 4 years, right? So it means this is gaining interest for 4 years, right? And the interest that it is gaining was 8.8%, 8.8%, right? Now, what I want, there's two ways to do this. You can find what the outstanding balance is at the end of 3 years, subtract the 100,000 and then calculate the interest it will gain for 1 year. But that is a long process. Instead, you will consider this as an investment of 100,000 here, right? Which will be for a year. So you get how much this would have gained if it was being invested for a year. And then from here, you will then say, let's call this one A, let me call this one B. Then for you to know how much Selby will have, you will then say A minus B. Why are you doing this? Because the A is to say, Selby was keeping the investment as is for the 4 years. But now there's 100,000 that needs to be withdrawn from this particular investment. So instead of us withdrawing it as 100,000, let's first get how much interest this would have gained so that you can subtract it at the end instead of subtracting it there from T3, because that makes it a bit of a long calculation, right? So this means that the 100,000 is only invested using compound interest, because this is a once-off amount that we are trying to find how much it is going to gain interest for. And this is kept there for 1 year, which is 4 quarters, because it is compounded quarterly, and the interest is still the same interest, right? So instead of him really withdrawing, we're saying, no, he's keeping it the same way as is, but he wants to withdraw at the end to say, how much would I really have if my idea was to say, concurrently, there's 100,000 that is being saved for that particular 1 year. So as a result, this will then be A is equals to P into 1 plus I raised to the exponent of N. I know that my P will be the 100,000, 1 plus, and then my I will be the same interest as what I have, 0.088 divided by 4. And all of this will be raised to the exponent of 1 multiplied by 4. I think with this one, for it to make sense to you, please try to write it as 1 multiplied by 4, because if you just write it as 4, it might confuse you that you're still thinking of the 4 years instead of the 4 quarters for a year. And then we want to find how much this is going to be. To do that, it's going to be 100,000, open a bracket. My zeros are enough, right? So it's 1, 2, 3, 4, 5 years. And 1 plus 0.088 divided by 4, because this is being distributed on a quarterly basis, and my exponent is 4 there. This is going to give me 109,094 rand, right? So 109,094 rands, and how many cents this is? Cents is 68. This will be 68 cents, right? Now, for us to find how much the Selby will have, so Selby will have, right? And then you will say the future value minus the A that we just got here, and that will give us how much Selby will have. So let's quickly go back and write down what value we got for the future value. It was 227,177, right? So this was 227,177 and 82 cents, right? This is 82 cents. Then from there, you're going to subtract the 109,094.68. And then you will then find how much that is. And to do that, I will just say minus 227,177.82. It's going to give me a negative. It's just because I started with a small number, right? But it's really one and the same thing. And this is going to be 118,083 rands. 118,083 rands. And how many cents? And 14 cents. Right? So now let's understand what this simply means. Instead of us subtracting this 100,000 at T3, which I'm going to try and show you quickly how to do that, we are instead saying, what if we said this 100,000, we want to find how much it would have accumulated for 1 year, and then subtract that from what the 12,000 that is being paid on a quarterly basis would have accumulated to at the end of the 4 years, instead of using T3, T4, and all of that. So please just understand that. I hope that makes sense. It's just one of those questions that need you to know what the timeline of the question is. Is the money going out? Is the money coming in? Meaning, are we depositing or withdrawing? And then you show that in terms of a timeline. So if we were to find the outstanding balance, this is what we would do. Right? So firstly, what you would do is you would say the first calculation will be 12,000 for 3 years, right? So you'd find that, and this is at 8.8%, right? So I will then say F is equals to 12,000 into 1 plus 0.088 all over 4 to the exponent of 3 multiplied by 4 minus 1 divided by 0.088 over 4. And then you will find what that answer is. And then number 2, we will say F minus 100,000. Right? That's the withdrawal that we are talking about, right? That Selby made into this particular, that he made from this investment. And then lastly, you will then say A, not A even, it's still future value. You will say future value because it's still on a month-to-month basis. And this will be 12,000, right? And this 12,000, you will need to understand how much this is gaining for 1 year. I to the exponent of 1 multiplied by 4 minus 1 divided by I, and then add this to the balance that you got here if you compound it per month, for a year. So do you see, this is a very long question, but the short way of doing this, as I said, you just need to try and do that one there, where you compound the 100,000 for a year, subtract it from the future value that he would have got in 4 years' time, and that gives you the balance that he will have at the end of the investment. And that's definitely what you needed to do with this particular question. All right, guys, that's it from me for now. I want us to take a quick ad break, and when we come back, we're going to be then doing some more questions on revising financial maths. Please stay tuned and take a walk, drink some water, come back refreshed. I'll be back just now. Hi guys, welcome back. So we are still looking at revising financial maths, right? So we looked at how to answer questions that are based on the future value. Now we're going to try and move on into present value to try and see what are the different questions that we can get there. And I promise you, the next question that we are going to do, it does not look like it is present value, but it is a very interesting way of looking at what present value is. So let's just have a look at it. So The formula that we use to calculate the present value annuity is normally the P is equals to X into 1 minus, open bracket, 1 plus I all to the exponent of minus n divided by I. You know you don't need to memorize or cram this formula, right? You just need to know when to use it because it is there in the information sheet. And then P is normally the balance outstanding because that's the money that you took as a loan. So that's the balance that is outstanding, or a bond, or a hire purchase in terms of buying a car. And then X will be the value of the installments, N will be the number of the repayments, I will be the interest rate as a decimal. You know it's the same thing with the future value. It only differs with the formula itself and the letter P to mean present value. Now, let's read this question. William receives an amount of 2 million upon his retirement, right? It's a lot of money, but when you are retiring, it might be very little. And then he invests this amount immediately after getting this money at an interest of 9.3% per annum, and this is compounded on a monthly basis. He then needs an amount of a very expensive current lifestyle, that is the amount of 35,000 per month in order to maintain his livelihood. He plans to withdraw the first amount by the end of the first month, right? For how many months will he be able to live from this investment? Now, let's quickly analyze what is happening here. Present value is all about the money you get now, right? It's all about the money you are getting now in order to settle it or to make it become from hero to zero, right? Just to make a typical example, from hero to zero, meaning from a very large amount of money to zero. That's how a loan works. You borrow money, it's a lot of money that you borrow. It doesn't really matter how much you borrow. But at the end of the loan, you must be at zero balance in terms of that particular loan. So even with this, it's the same concept, right? It's like a loan that this person is getting from their retirement fund, right? They're getting 2 million. And they say, instead of me just having it in my account and trying to eat it as little by little to use it in order to maintain my lifestyle, let me put it in an investment account and then I withdraw from the investment account on a monthly basis. So what is this doing? It is going to make him move from having 2 million. After 1 year, it will roughly be less than the 2 million, but because it's gaining interest, it will make it a bit better. But after, let's say, maybe 10 years, you will think this person will have zero balance in the bank, right? Because every time you withdraw something, they recalculate the interest on the balance that's remaining. So this is present value, although it does not talk about loan or bond. So I'm just trying to show you. The other example, by the way, is if you get a bursary. If you get a bursary from any company or from the government or from however you get the bursary that takes you to school for higher education, that bursary, they say, we're going to give this person 100,000 for the first year. That's a loan. It works the same way as a loan. Why? Because you get 100,000 now, at the end of the year, it's going to be zero. And that's how a loan works. Whereas future value, you move from zero to hero. So you start with nothing, pay regularly until you get to something big. So it's a very interesting way of you looking at present value. I just thought if we were to squeeze this in, it will give you an idea of how else they can ask you about present value. So to solve this, I will then say my P is 2 million, X is the monthly payment. It's the same as like monthly payment, but it's actually a monthly withdrawal of 35,000. N will be what we are trying to find. We know the interest is compounded on a monthly basis. And therefore, I will then say P is equals to X into 1 minus 1 plus I to the exponent of minus n, all of this divided by I. And then I know this is 2 million, 1, 2, 3, equals to 35,000, 2, 3, 1 minus 1 plus, the interest will be 0,093 divided by 12 to the exponent of negative 12, n, because we're going to multiply that by 12, right, since it's compounded monthly. And then it will be 0,093 divided by 12. Then we go straight to the calculator. From there now, I'm just going to do it all at once on the calculator. Firstly, it will be 200,000, which is 2 million, and then multiply this by the fraction, which is 0,093 divided by 12. This will give us 15,500. Then I'm going to divide this by the 35,000. I'm just performing the calculation that you will normally be doing as you are writing down, right? I'm just doing it all at once because going from calculator to the board is a bit of a problem. And then I will have that much, and then with this much, I will then say 1 minus this answer, which will give me that. So this will be 39/70. So it means now I am left with 1 plus 0,093 over 12 to the exponent of minus 12. N is equals to, I think it was 39/70. But I will just verify for you now. Yes, 39/70. Then from here, this will be negative 12. N is equals to a log of the base, which is 1 plus 0,093 divided by 12. And here I will have my 39/70. And I want to find this, what the answer is there. Before we quickly do that, we need to find out. Remember they said how many months. So that means we do not need to convert what we are going to get here into years after we get it. So this is going to be the log of, down here it will be 1 plus 0,093 over 12. That's my base. And in there, it's going to be the answer, which is the same as 39/70. And that's going to give me a negative number, but I'm going to divide that by negative. That is on the left, so I'm just going to get 75 months. So this is then going to be 75 months that this person is going to live off this thing. So if you're looking at 75 months, you know 36 months is like 3 years, another 36 months, you know. So 60 months is like 5 years, and then an additional 13 months, because this is on a 75, an additional 15 months. And that's how long the person is going to live off this amount. So after 75 months, the balance in his investment will be 0. And that's the whole point of present value. So I really, really hope this is giving you an idea of how else we can ask you to try and use the present value formula. But for now, I want us to take a quick ad break, and I'm going to be back with some more of the present value questions that we're going to do together. So please stay tuned. I'll be back just now. Hi guys, welcome back. I hope you had a bit of a nice rest there and you reflected on what we've just done. So right now we are going to answer a bit of more questions. Now these are straight to the point. They specifically show you, or the words that they use, a clear indication that we are talking about present value. So let's just look at them and then answer them together. So the very first question says, Sarah takes out a home loan over 20 years to buy a house that costs 1.5 million, right? And what we then want you to do is calculate the monthly installment if interest is charged at 10.5% per annum, which is compounded on a monthly basis. So this, in simple terms, it means we know what P is because we are talking about a home loan. We need to find what X is, and the period is for 24 months because 20 years is the same as 24 months. And then the interest is 0.105 divided by 12. Now, my formula, you know, this will be P is equals to X into 1 minus 1 plus I to the exponent of minus n, all of this divided by I. Now, some people, they prefer making X the subject of the formula. It is entirely up to you. So we will do that so that we can just press everything on the calculator. So if I do that, it will be X is equals to P multiplied by I divided by 1 minus 1 plus I to the exponent of minus n, right? If you make X the subject of the formula, because that's what I'm trying to find. And this will be 1,500,000 into 1 minus, and this will be 1 plus, my interest is 0,105 divided by 12, and this is raised to the exponent of negative 240. And all of this is going to be, I'm substituting as though my formula is still the original one. You see. Okay, let me just quickly fix that. So this is multiplied by 0,105 over 12, and all over 1 minus into 1 plus 0,0105, 0,105, yes, without the additional 0. Okay, and then all divided by 12 to the exponent of minus 240. And then from there, you can just simply go straight to the calculator. And on the calculator, you'll say 1,500,123 multiplied by 0,105 divided by 12 all over, so I must take this down there, 1 minus, open a bracket, 1 plus another fraction, which is 0,105 over 12 raised to the exponent of negative 240. And that will give me 14,975, right? So that will be X is equals to 14,975 and 70 cents. 75 and 70 cents. All right, so that's the monthly payment. And look at that. The house is 1.5 million, but you're going to be paying 14,900 a month. Interesting. So calculate the outstanding balance immediately after the 144th payment that was made. Now we need to understand what outstanding balance is all about, right? We know this is the monthly payment, right? We know this is the loan that we have. That's the duration that we're trying to find the outstanding balance for. So when we're trying to find the outstanding balance, which I'm going to call OB, this is going to be equals to the present value into 1 plus I to the exponent of n minus x into, now we're going to factor in this calculation the future value, right? And I will explain now why we are introducing future value here. Now, please understand what is happening with a future, with an outstanding balance. Outstanding balance means you are trying to find how much would have been the cost that this person needed to pay, right, for that duration, minus how much did the person pay on a month-to-month basis for that duration. hence future value, because future value is something that accumulates, right? You are paying on a month-to-month basis. Hence the formula that I have on the board. I promise you, you can do it bit by bit, where you find how much the loan amount is going to be for 144 months, and then find how much this person contributed for 144 months, and then subtract. It's perfectly up to you. Or you can just go straight to pressing the calculator with that formula that I have on the board. But I'm going to choose this one because it's a bit shorter for me. It can also be shorter for you, but always work with what you understand best. Now, this will then be equals to the present value we know is 1.5 million into 1 plus the interest we know is still 0.105 divided by 12 to the exponent of 144 minus this person was paying 14,497 and 70 cents, and they were paying this for 144 months and at an interest of 10.5% still compounded monthly, right? 144 there minus 1 divided by 0.105 over 12. And then from there you can just go straight into the calculator to find what this is going to be. So I'm going to calculate it bit by bit, right? So that it does not overload this calculator of mine. 1 plus 0.105 over 12. This is raised to the exponent of 144. And that will give me that much. And then I must subtract the future value from there. So 14,497 and 70 cents. 1 plus 0.0 or 0.105 over 12 to the exponent of 144 minus 1 all over another fraction 0.105 over 12. And then you find what the answer is. So the outstanding balance after 144 months, this will still be what is outstanding from this loan. So that will be 1,106,834. 834,71, right? So this will be the outstanding balance that will be remaining. So quickly, let's just verify what's happening here. So 144 months is the same as 12 years. So for 8 more years, this is going to be calculated on an interest of the same 10.5 that they will still need to pay. So you can see that it's a bittersweet moment, but at that time it will be for a good cause. Now, another kind of calculation that you will need to be talking about is, they say a small business owner was granted a loan for purchasing 100 cellular phones. He paid, right? So firstly, we need to understand, now we don't know what the total cost was, but we know that it was for 100 cellular phones. And this person was paying 4,800 less a discount of 13.5% for each phone. Then the loan had to be repaid in installments at the end of each month at an interest rate of 7%, compounded monthly. Calculate the monthly installment if this is being paid in 5 years' time. So what do we know? We know that he paid 4,800 less a discount of 13.5% for each phone. So in simple terms, it means you need to get what is 13.5% of the 4,800, right? And then whatever that you get here, you are going to say 4.8 minus this answer that you are going to get there. So this is going to be 4,800 minus 13.5% of that is the same as 13.5 over 100. Multiply this by 4.8, and this will give me 4,152. So this is how much he's actually paying for each phone, for the 100 phones. And then we are going to multiply this by 100 because he bought 100 phones. And this will give us 415,200. Hence, the calculation that I have here, my p-value will be that, because this is the actual amount that this person is paying because of, buying in bulk and all of those other benefits there. Now, this is for 5 years, so it's for 60 months, and the interest is on a 7%. So from there, I will then want to find what the x is. I will say p is equals to x into 1 minus 1 plus I to the exponent of negative n divided by I. Please remember to start with the formula at all times. This will be 415,200 x into 1 minus 1 plus my interest is 0.07 over 12 to the exponent of negative 60 divided by 0.07 over 12. Then calculator all the way. Multiply this by 0.07 over 12. And this will give me 2,422, and then I will need to divide this by the whole thing that is inside that big bracket, which will be 1 minus 1 plus 0.07 over 12 raised to the exponent of negative 60, and then I will close my bracket. So that will give me the monthly amount, which is going to be 8,222 and 21, right? So this is going to be, x is going to be equals to 8,221, and I think it's 57 cents. Oh, 46, not 57. I missed the 4. Right, so this is going to be 46 cents that this person is going to pay, 46 cents. So it's going to be 8,221 and 46 cents. So the first thing you needed to do was to get what is 13.5% of this amount, and that 13.5%, you're going to subtract it from the original price of each phone because this person got a discount. Multiply that by the number of phones they are buying, and that will be the actual loan that they got from the bank. And then from there you can then start calculating. So please just make sure you're always on par with what needs to be done before you do the calculation. Now, to summarize what we've been looking at, you need to please understand the difference between compound and simple interest. We know they normally say compound interest is interest on interest, when simple interest is just a constant interest for the duration of your investment. We also have what we call the nominal and the effective interest rate. The nominal is what I give you for the year. The effective is when I now start to break down what I gave you for the year in months, in quarters, in half yearlies, or in daily, or in weeks, because at times they can be a bit interesting by saying compounded daily. You also need to know the difference between the future and the present value. Please try to always use timelines to analyze data that is given to you, because some data is not as straightforward that you will just go straight into calculation. At first, you need to understand, what is this thing saying to me? And to do that, I won't lie to you, Matt has done a very great job by giving us a timeline, because this assists us in seeing whether the money is coming in, going out, coming in, going out, when is it going out, when is it coming in, and all of that. And you will be clear on how to actually do the calculations. But guys, right, really, you know that financial maths is the greatest topic out there, because it really, really, really teaches you a lot about just personal finances in life. But you know, if you need more help, you can always consult people. But because you guys have got me as your maths doctor, I believe that you'll be able to make some decisions that are wise in your life based on what we've done thus far. From me to you, I hope you've learned so much and I've enjoyed doing all of this with you, and I hope you also have enjoyed. Remember, mathematics is food for the soul. Until next time.